Lesson: Managing AI Model Lifecycle and Version Control. Managing the lifecycle and version control of AI models is a critical component of AI model deployment and maintenance. This process involves overseeing the development, deployment, and continual refinement of AI models to ensure they remain effective, efficient, and aligned with organizational goals. As AI applications become increasingly integrated into business operations, understanding the intricacies of model lifecycle management and version control is essential for AI professionals seeking to maintain model effectiveness and deliver consistent value. AI models undergo several phases during their lifecycle, including data collection, model training, evaluation, deployment, monitoring, and refinement. Effective management of this lifecycle requires a structured approach that incorporates version control to track changes, ensure reproducibility, and facilitate collaboration. One of the central challenges faced by AI professionals is maintaining the integrity and performance of models over time, particularly as data distributions shift and business requirements evolve. Version control systems, such as Git, have been widely adopted in software development and are equally applicable to AI model management. Git enables teams to track changes to code and model parameters, allowing for robust collaboration and easy rollback to previous versions if needed. In practical terms, managing an AI model's lifecycle begins with the collection and pre-processing of data. It is imperative to establish a data pipeline that ensures the data fed into the model is clean, relevant, and representative of the problem space. Tools like Apache Airflow and data versioning systems, such as DVC, can be instrumental in managing data workflows and ensuring that datasets are versioned alongside the models they train. DVC, in particular, extends traditional version control to handle large datasets and model files, integrating seamlessly with Git to provide a comprehensive versioning solution. Once data is prepared, the model training phase involves selecting appropriate algorithms and tuning hyperparameters to optimize performance. This phase is iterative and requires tracking of various experiments to identify the most effective configurations. Experiment tracking tools like MLflow offer a robust solution for managing experiments, recording metrics, and storing artifacts, thereby enabling data scientists to systematically compare model performance across different runs. Deployment of AI models into production environments presents unique challenges, necessitating tools that ensure models perform as expected under real-world conditions. Docker and Kubernetes have become standard tools for containerizing models, allowing them to be deployed consistently across different environments. This approach enhances scalability and simplifies the integration of models into existing infrastructure. Furthermore, serving platforms like TensorFlow, Serving or TorchServe provide specialized environments for deploying and managing machine learning models at scale, offering features such as model versioning, dynamic loading, and API endpoints for real-time inference. Once deployed, continuous monitoring of AI models is crucial to detect performance degradation or drift in data distributions. Tools such as Prometheus and Grafana can be integrated to monitor model performance metrics, while automated alert systems can notify teams of anomalies. Additionally, A/B testing frameworks allow organizations to compare the performance of different model versions in production, facilitating data-driven decisions on model updates. The refinement phase of the AI model lifecycle involves updating models based on monitoring insights and evolving business needs. This process is streamlined by maintaining a robust version control system that tracks changes to both data and model code. GitOps, an operational framework that leverages Git for continuous delivery, provides a structured approach for managing model updates, ensuring that changes are consistently applied and documented. Real-world case studies highlight the importance of effective AI model lifecycle management. For instance, a leading e-commerce company employed a comprehensive model management strategy to enhance its recommendation systems. By integrating tools like MLflow for experiment tracking and Kubernetes for deployment, the company achieved a 15% increase in conversion rates and reduced model update cycles from weeks to days. This case underscores the value of a systematic approach to model lifecycle management in driving business outcomes. In conclusion, managing the AI model lifecycle and implementing version control is integral to maintaining model performance and delivering sustained business value. The use of practical tools and frameworks, such as Git, DVC, MLflow, Docker, and Kubernetes, equips AI professionals with the capabilities to address real-world challenges effectively. Through structured lifecycle management, organizations can ensure their AI models remain robust, scalable, and aligned with strategic objectives. The integration of these practices not only enhances model reliability, but also empowers teams to innovate and respond agilely to changing market demands.